This question asks us to draw 3 constitutional or geometric isomers of C3H5Cl. When you read the term constitutional or structural isomer, you should recall that these are isomers in which the atoms are joined in different ways. And when you read geometric isomers, you should think of cis and trans. So this is a good clue that the structure might contain a double bond. Once you understand what the question is asking, make a plan. Start by drawing one possible structure of the molecule C3H5Cl. Connect the carbon atoms, add the 5 hydrogen atoms and 1 chlorine atom, and you'll see that we don't have enough hydrogen and chlorine atoms to give each carbon atom 4 bonds. We'll need to add a double bond. Okay, there's one molecule finished. To get structural isomers of this molecule, we'll need to draw structures with the double bond in different locations. And to get geometric isomers, we should check for the possibility of cis-trans configurations of the double bond. Let's solve. To get a new structural isomer, we can simply move the double bond over to the other carbon atom. Don't forget to shift a hydrogen atom too, so that each carbon atom still has 4 bonds. To get a new geometric isomer, notice that the chlorine group and the methyl group in the first structure are trans with respect to one another. If we switch positions of the hydrogen and the methyl groups on one side, then we can get the cis isomer. There, now we have 3 isomers of C3H5Cl. When checking your work, you may find that you've ended up with somewhat different structures. That may be okay. These are also acceptable isomers. To be sure that your set of isomers is okay, make sure each structure has the correct formula, 3 carbon atoms, 5 hydrogen atoms, and 1 chlorine atom, and check that each atom has an octet. Finally, check that none of your structures match each other after you've flipped or rotated one. If everything checks out, you're finished.